Robopapa.
Okay, so in order for us to actually build the box, the security box, I'm using the Radio Shack, basically project box. It's one of their bigger size one. They usually coming with also a metal plate on top of it with the screws, but for this case we will not need it. Just to mention, this actually build will take 2 episodes, and this episode will show in the breadboard what we're doing and how it all works. And then next week episode we'll actually build everything together, minimize it to a PCB, and then install it within the box. So stay tuned for next week for how we're actually building it. So for now, let's go to the PCB itself. And this is all the components that I wanted to have, or the items that I wanted to have within the box. One is a keypad, that way we can actually put in a password in and locking it and opening it. I wanted to have some lights to indicate if you were right or wrong, or when you're updating the code to open it. Some sound that can actually tell you if something is good or bad. And then a way to lock it. So the way we actually achieving it is the locking is actually going through just a regular servo. That way we don't need to worry about a driver, like a motor driver, because it has already within the built-in components for it. Plus we will just need like a 90-degree probably leverage that can go like as close or like and open. That way we can lock and open it with ease. For the keypad, we're just going to use this Matrix keypad. It's a 4x4. We don't need more than that. Then we have an RGB LED. Let me try to zoom in to the LED itself. So we have an RGB LED. That way we can show like red for you had the wrong password, green for you change your password, and then blue, I think it's for successful. And then we have just a regular Piezo with some tunes set up for it. So let me power it up, and then we can show the demo, and then after that we can look at the code. So it started. The way to start, you pressing, for example, the hash key, and let me zoom out a little bit, and then let's say 1 2 3 4 and hash. So you can see that now it's open, and then to lock it you do the same password. So the password, and then pound again. If you enter, for example, 00, you can see the LED was actually red and you had the wrong password. And then we'll open it, then we can change the password. So let's *124*. Now we're green, so we can do #124#, and change that again. So that's basically all the functionalities and how it is. It looks kind of messy right now, but let's move to the computer, that way we can see how the code actually works. Alright, so here we are in the code. I just have Visual Studio started, and I'm using the Visual Micro. It's a freeware where you can download and will help you build if you don't like the Arduino IDE, and would like to just do some cool stuff with the Visual Studio. I might just do a video about that in future episodes. So I defined the E prompt, that way we can actually save the password that we're entering or updating, and we use the keypad and key modules. That way it's the modules for the keypad itself, and of course the server itself. Pitches.h is just predefined sounds that I created, or tunes that you can create. I didn't create it, it's something somewhere I found online, but I'll post the code within my website, that way you can actually have that as well. Then I define certain things like open gate, which is 90 degrees, and close gate is 0 degrees. The red, blue, green
pins are A0, A1, and A2 of the Arduino. Then a couple of enums for me to know where state I'm in within the code or within the password, etc. Couple of um, functions declarations ahead of light, so reset objects or turn light on, and it tells it what color to turn it on. This is where we define the keys for the keypad and which pin is actually connected. So 2 to 5 is for the rows or the columns. I'm sorry, and 6 to 9 is the rows themselves. Um Starting a keypad object where you defining what are the keys and then the rows, the columns, and then sending the values, how many rows and how many columns. So it's 4 by 4. Um, then I have some master code where you can enter it, and no matter what the original password or the changed password is, you will still be able to open it. So as a father, if you want to sneak into your kid's box, not that you want to, but if you want, you can do that. Um, it's coming from previous code that it's like up, up, down, down, left, right, and then I think it's ZX, if I'm not mistaken. I can't remember what it calls, but there's like some sequence like this that people likes to put. Um, so just defining certain objects like state of the lock is locked now. Right now, password state is invalid, um, and just setting up some variables. This is where the melodies are for success and failure, and then the duration. So that gives you the frequency of it, and then the key tones are basically this. So each key has its own tone in it. Um, in the setup, just start preparing those modules and the objects. And the first thing is I'm trying to get from the EEPROM the password, and then by default it's 1234. But if you're changing it, the next time that you will load, it will actually load the new password. But when you're starting and your EEPROM is actually empty, it will set it to default. So I'm trying to read that address, which is address is 0, I believe. If it's -1, that means it doesn't exist. I'm sending the EEPROM to 1234 by the put. That way, every time I can actually get it, and I will put that into the safe password. Um, Setting up some pin modes, and then starting the loop itself. I'm getting the state of the keypad, and if it's released, so every time that you're pressing something and then you're releasing, that's where I'm initiating the read in a way. Um, we're going through the different states. If it's a valid, is it closed, is it open? Then turning the green LED. So turn light on, and then it says green, and then delay, and then blank. We can look at the light and the function turn light on. It's fairly simple. Similar thing is if it's invalid, closing the gate and turning the light to red, and you're resetting the object. The object is basically um, what password you already entered, and that way we can validate or invalidate if what you enter is correct or not. If it's on the state of finished, then um, that's basically where you want to put that into the EEPROM as the new password. That's in case that you're on a new password pattern. Playing the tone, it's just some function that I found online that goes through the melodies and then playing it. Where no tone 8, it's basically just a delay of the no tone. Here's the reset objects. Turn light on is blank, so you turn off the light. Start new password is none. Start enter password is none. So basically initializing everything to the beginning. The turn light on is just taking a color, and then delay in milliseconds is 500. and this is where, depending on the color, that's what we're turning on and off. So red pin, blue pin, green pin, high, high, low, that gives you the green. And that's how we actually changing the lights depending on what color we actually pass to this function. So very straightforward. In the keypad event, that's like the keypad, it will send and raise an event, the name keypad event, and it will pass it the key. And this is where we switching on the state of the key. If it's a release, and this is the only event that we're looking at, so you can press it until you release, it will not initiate that. So when you're releasing, it's looking to see if the key itself is hashtag, a star, or anything else, as you can see over here. Hashtag, that means that the new password started. That's how we know that you started a new password, and then new password update state. We're just updating the state for the new password. Otherwise, it's basically you enter a new password, right? If you remember in the beginning, you need to start the password. When you want to start to enter the password, you're pressing the hash key, you're entering your password, and then to finish, you click typing again the hash key. If you want to start a new password, you're doing the star. That gives you the initiating the new password starts. And then any other key is, if your password started, we'll do that, which press key, and then we're validating that what is the like, if until now your password is correct or not, and then start new password. Once again, we're updating the new password as you entering that, and then no matter what, we're always playing the tone of that key, which, if you remember, it's set up right over here. Um, Other than that, um, here's the play key tone. Depending on the keys, 0 to 9, it plays this. And um, basically, all I do is taking the key tone and I'm converting the string or the character 0 to 9 to really the index of it. Because 0, 1, 2, 3 to 9, those are the melodies for this. For A, B, C, and D, I just need to take the ASCII value as the integer value minus 55, because those will give me the next character, the next index of those characters. And then all I have left is the hash key, the star, and then default is there's no sound. So by using the integer value of the hash key, I can actually assign that to the right index. Um, Update new password. It's just, very straightforward. Just some logic in it. I don't think that I need to go through and show it to you. I will post all this code in my website. That way you can download that if you want to. So that's it for today, guys. If you have any questions or comment, please leave them in the comment area below. I will post the link to the code for my website in the description. And as always, please subscribe. It's helped a lot and tells me that you like what I'm doing. Thanks, guys.